Hello there, ladies and gentlemen. Root Beer here. Hope you're doing well. I wanted to share with you some math that I just learned about. So I recorded my 9-point circle video about 2 hours ago, and during one of my break periods, I read up on the subject. It's nice, always a good idea to refresh your mind a little bit. And I learned that there's an even better, well, not better, but there's a nice generalization of the 9-point circle to the 9-point ellipse and the 9-point conic. So there's a 9-point ellipse, a 9-point hyperbola, and I figure I'm going to try and show you how to do that. So with our segment tool, we start with a triangle ABC, and then we got this extra point D, and we're going to use that to create the 9-point conic. So what 9 points are we going to be working with? Well, the midpoints of the sides, that's definitely something we're going to need, just like we did with the 9-point circle. So let's get those going. What happened there? There it goes. So we need the midpoints of the sides, and this is simple enough. We saw how to do this in the 9-point circle video. Perpendicular bisectors finds the midpoint, and what's the other one we need? We need BC. We need the midpoint of BC. Okay, so right down there. So these guys happen to all run together. They run together for the midpoint of the circumcenter, but we don't actually need them for that. So let's get midpoints of the sides. And then those are 3 of the points we need. And then we need 6 other points. And then we'll have 9 points in total. So what are those other points? Well, let's talk about them while I'm erasing our rough work. So the other 6 points are determined with the help of D. It's D and the circle. Now, if we're just doing the 9-point, sorry, not D in the circle, D in the triangle. If we're trying to do the 9-point circle, D has got to be the orthocenter. We computed the orthocenter when we did our 9-point circle. So how do we do the 9-point circle? Well, we constructed some altitudes, and the feet of the altitude, so where the altitude running through C hit AB, that was one of the points we needed. And then the altitudes intersected, and we got the orthocenter. And then it was halfway between the orthocenter and the other vertices. So to get the conic, we'll use D. We'll draw the line C through D, and halfway between that will be one of our points. And then when we extend that line, wherever that hits AB, that will be one of our points. Okay. So it's actually there's less work because we don't have to find the orthocenter first. Now it's just this point here. Let's get A to D. So we will have to extend. I should probably delete this point. GeoGebra tends to get touchy if I don't have the extended line. So let's extend all the lines and then get D through each of those. Okay. So now let's talk about intersections. So there's an intersection of DC through AB. How about DA? Where does that intersect BC? Right here. So that's going to be a point on our, not circle, but a 9-point conic. And now DB, where does that intersect AC? Right here. Okay. So we're looking good. Now what else do we need? We need midpoint of DB. We need midpoint of DC. We need midpoint of DA. So more midpoint work, but nothing too hard. Nothing that's gonna impede our progress. What might impede our progress is the 5-point conic tool, which has been, in the past, for me at least, a little touchy. So we'll hope that it works there, but now we got the midpoint of AD. How about the midpoint of DC? So standard bisector trick. There we go, and now we just need one more. I'm going to take the time here to clean things up just because I think the circles are going to get a little messy after a while. So any non-red points can go. There we go, that's looking much better. And now midpoint of BD. Okay. There we go, and we'll have to zoom in just a little bit to make sure we get the right point. And we'll color them red. And now everything not red can go. And we should, in theory, these guys sort of look like they're on an ellipse. So I specifically chosen D so that he was bound by two of the extended lines. We'll get a parabola. I'll leave these guys here for just a moment, or I guess redraw them while I erase the other things. But depending on where D is, we get different conic figures. So if D is anywhere here, we should get a parabola, or sorry, not a parabola, an ellipse. And then if it passes off into the interior, we get an ellipse, and then if D is the orthocenter, we happen to get a circle. We saw that with the 9-point circle. But if D is out in this range, we get, or we should get, a hyperbola. So I'm going to keep D over here, and then I am going to hope that my conic through 5-point tool, 2, 3, 4, 5. Look at that, there it goes. And it really is an ellipse, and everyone is on it. And then we get a hyperbola. And that's something that I only just learned today. You might have already known about it, but I think that's pretty nifty. So we can get a circle if we place D just right on the inside. I don't actually know where that would be. But other than that, we get an ellipse. Now, D isn't particularly special. I don't think he's a focus or anything. If he were a focus, he would have to be the center when it's the 9-point circle. But no, D acts where the orthocenter is, and the orthocenter is not the center of the 9-point circle. So I don't think D is a focus or anything awesome like that. But we do base the whole thing off just this triangle, A, B, C, and our point D. And if he gets on a line, we get sort of a degenerate two parallel lines hyperbola. And that's okay. He comes up to a vertex. Oh, we get some interesting stuff when he's around vertices. It bounces around. And then my understanding is if we... So I was reading a paper and it said if you take D out to infinity, you sort of get parabolas as a limiting case. Maybe that's over here. Because if you... as we pull D, this ellipse is stretching out a fair bit, and a parabola can be viewed sometimes just as an ellipse where one of the foci is in infinity. Now, I know D isn't a focus, but I feel as D gets pulled, one of the foci is getting pulled sort of with D. Here it's obvious that D is not a focus because the focus has to be, or the foci have to be inside the ellipse, but I still think that this is just... it's so cool. It's stuff I didn't know. Like, obviously, you can't draw an ellipse or a hyperbola with a compass and straight edge. That's beyond compass and straight edge. But we can set up all the points with compass and straight edge. And then, yeah, we get a 9-point ellipse. We get a 9-point hyperbola. Can we make them touch? Gets very close. I'm sure there's a degenerate reason why maybe if AD happens to line up with the midpoint or something like that, we get a degenerate case. I'm going to be playing with this and moving it around after the video, but I wanted you guys to see it. And now you can do it at home too, and depending on where you pick your starting point D, if you're using pen and paper, or pencil and paper you should be using, or if you're using a program like this, of course you can move D around just like you can move your triangle around. But depending on where you choose your D, you get ellipses, hyperbolas. You might even happen to get the circle if it's just the right spot. But yeah, based on our construction, if D is the orthocenter, you do get the 9-point circle. So this is a fun little add-on, so I wanted to make a follow-up video. I think that's pretty nifty. So thank you guys for watching, and if you like this as much as I do, like, subscribe, all the fun stuff. I don't like trying to push that on you guys, but it's nice to know that you guys out there watching like the same sort of stuff I do. And I certainly like this construction. I think it's pretty cool. I'm going to be talking about it with some of my math buddies for a while. But I will leave it there. Have yourselves a wonderful day. And who knows what we'll find in the future, what I'll make videos on. I'll see you guys in some future math video.